I had Desmos graph the function y equals x to the 5/3. And limits are going to be from 1 to 6. So we're going to want to stop there and start here. So to make a volume of revolution, you want this kind of thing. And it'll look like that. So there'll be all these slices, which are like discs or washers, is the idea. So now you want to identify just a typical slice. Just a typical washer here. So that could look something like this. Sort of like a quarter or a dime. Alright. Now you're going to want to cut it up along the x-axis, so this is going to have a width of dx. And then each slice will have an area, which you could call A, but it would be a function of x. Every slice will have a infinitely small volume dv, and that would be given by the area as a function of x times dx. Okay, yeah, because you got to find a formula for the area of each washer, which will change. Dx will be the same for all the slices, just like an infinitely small, piece of x. So what you'd want then is to figure that the area has the formula pi times r squared. So you've got to figure, okay, every slice's area is different. Like this guy, he's got an area that's smaller than this one. So whichever x we're located at determines how big the area is going to be. Like the one over here has the smallest area, And so we got to find out like how to quantify that area, like how to decide how big it is based on where we're located. Because if we're located at 1, the area is small. But if we're located at 6, the area is huge. And so we need a mathematical formula to predict what the area is going to be. One way to do that would be to figure that you could find the radius as the height. The radius would be the height of the function, actually. And that's something we have a formula for. So like here, the radius at x equals 6 is going to be 6 to the 5/3. That's just using the formula for the function. And then over here, it's going to be, wherever we are, like 3.5, I guess. We'd be at 3.5 to the 5/3. And over here, it would just be 1 to the 5/3. Does that make sense? Like how the x that you're at determines how large that green line is? So you just plug that in then in place of your r of x formula. So see, r of x is going to be the function, x to the 5/3. That's the radius. So you just plug that in. You go pi times x to the 5/3 squared dx. It's all about just like building it up one step at a time, and you want to get it all in terms of x. Alright, so then once you plug that in, now you would integrate both sides. And then you'll get the total volume. The volume will be an integral from x equals 1 to x equals 6 of pi times x to the 5/3 squared dx. And that would be the setup. So if you just plug that into Symbolab or Graphic Calculator, you'll get an answer. However, some of the questions are picky where they want it in an exact format. So you may want to use Symbolab because Graphic Calculator will typically only give you an approximation of the final answer. Yeah, I'll plug it into Symbolab now and see what it tells me. Alright, so we'll enter from x equals 1 to x equals 6 pi times x to the 5/3, square that, and then dx. That should do it. It does.